Welcome to this special episode of Frequency Matters, the RF Microwave Update Series. I'm Pat Hindle, and today I'm talking with Tom Cole, Vice President of Sales and Marketing at Integra Technologies. Welcome back to the show, Tom.
Thanks, Pat. Always nice to be back.
So we've been following Integra as you've been pushing the limits of GaN power for high voltage devices. And at IMS in San Diego this year, we saw live demonstrations of high power RF transistors and pallets at power levels that we've never seen before and that small of a form factor. How has Integra been able to achieve this?
So we've been pioneering high voltage GaN since, believe it or not, 2012. So for over 10 years. And in that, we have really learned a lot of generational knowledge with respect to how to do very high power devices, specifically high power densities, while still maintaining reliable channel temps. So that power density is really the key to what we demonstrated at IMS this year. So now we're able to push the single transistor power levels from 1,500 watts to almost 6,000 watts in P-band. And we've taken, again, a huge leap for S-band as well, going from 700 watts to almost 2,400 watts per device. And so with that, we give the tools to the system architects to really radically re-architect and redesign their systems to take advantage of a much larger individual transistor or pallet power. So that goes a long way towards helping somebody to what we kind of call realize swap C squared. So not just the size, weight, power, and cost, but also a massive reduction in complexity, which helps to drive these new generations of very, very high power systems in much smaller form factors than ever possible previously.
And how has the market reacted to Integra's high voltage GaN since you did introduce it way back in 2020? Are customers adopting the technology?
They are, and it's been actually really fun to watch. We've seen several systems now with very early adopters who jumped on the technology after we released it back in July of 2020, and now they're in production. And it's been really fun to actually visit them, go into the engineering labs, and actually see with our own eyes the reduction. So this power combiner, this power splitter, all these cables, all of that extra hardware that you need when you're combining relatively smaller transistors or pallets goes away. So it's been really an enjoyable and very satisfying event for us to go out and see these systems now and how much smaller they are for the same power delivered.
And we are seeing a trend towards software-defined RF and microwave systems, in many cases incorporating AI. Has Integra been aligning with its RF and microwave SSPA technology with this trend?
I agree with you. We see that trend very presently around a lot of the customer base, especially as systems are looking to become more dynamic and to be able to adjust to whether it's resolving a radar target or looking at high power microwave applications for defense. All of these systems share the same desire, which is to be able to benefit from machine learning to make the systems more effective. So at Integra, back at European Microwave in 2022, we introduced our digital pallet architecture. And this is really a very flexible, so think of it as a software-defined integrated control and command of an RF pallet. And so this platform has really been put together so that it wraps around our RF high power pallets. And now we can provide either in a completed form factor or the individual building blocks for a customer to drop in to their own SSPA. And that allows the maximum flexibility and an extension of our semi-custom approach, where a customer can now take that digital architecture and use it to wrap around an RF pallet, command, control, health monitoring, and all the other functions that can be done with that. And so we've really designed this as a modular approach and something that we look to see people really take advantage of and now be able to benefit from that digital control structure versus analog control loops of these RF amplifier pallets.
Yeah, I do remember seeing that European Microwave Week. It was a great small form factor with a lot of capability. So are there any other interesting trends that you're seeing in the market?
I think the biggest one that we see almost on a weekly basis is we are being pushed for combinations of ultra-wide bandwidths at power that were previously not realizable with older generations of semiconductor technologies. You just couldn't transform the bandwidth at power with conventional or previous generations of semiconductor technologies. So right now, one of our key initiatives that we're working with an agency and a number of industry partners is really to achieve incredibly wide bandwidths at multi kilowatts of power. And these are things now which would enable, again, system architects to take the advantage of these types of very high power devices and do form factors of very high power for defense applications in system form factors that were previously 10x the size. And so that's really an exciting trend that we've stepped up to that challenge. We're looking forward to producing more devices with this. And as you'll see here coming up in the next year, we're using some of this work right now to really mature our 5th generation high voltage GaN on SiC. And that's something that, again, will provide an ability for a system user to have a bandwidth at power that was previously unrealizable. So we're very excited and looking very forward to continuing to advance that technology.
Well, thanks, Tom. I really appreciate the update on the high power GaN market and how you're addressing it. It's doing a great job, and exciting products are coming out every year. So to our audience, you can find more videos at videos.microwavejournal.com. Thanks for watching.